All right, let's talk about C#. Specifically, let's talk about making our applications do more than one thing at the exact same time. We're going to learn how to create a true symphony of execution.
Think about it for a second. Have you ever built an app where you click a button to save a big file and everything just freezes? The whole user interface just locks up? If that sounds familiar, well, you've hit the wall of a single threaded world.
So our goal today is to shatter that wall. We're going to dive into how to execute tasks in parallel so we can build apps that aren't just faster, but actually feel alive and responsive to the user.
And to do any of this, we have to start at the very beginning, with the absolute fundamental building block of it all, the humble thread.
So what is a thread, really? Well, in the world of C#, you can think of it as the smallest possible piece of your program that can be run by the operating system. It's basically an independent path that your code can take, which is what lets different parts of your program run simultaneously. Okay, that definition's a little academic, I know. So let's use an analogy we can all get. Imagine your entire application is a bustling restaurant. A single thread is like one worker in that restaurant. You've got one person chopping vegetables, another person at the grill, and someone else taking orders out front. Each one has their own independent job. And just like a restaurant has different kinds of staff, C# has two main kinds of threads. First, you have foreground threads. These are your essential workers. Your app will keep running as long as even one of these is still doing its job. It's kind of like the last chef in the kitchen who has to turn off all the lights before they can leave. Then you have background threads. These guys are for tasks that aren't as critical. If all the foreground threads are finished, the app isn't going to wait around for them. It'll just shut down. Think of them like the cleaning crew that comes in after the restaurant is already closed. Okay, so we've got our individual workers. That's cool. But the real power, the magic, happens when you have a whole team of them working together. And this brings us to the art of multithreading. At its heart, multithreading is just that. It's the practice of using multiple threads to get different jobs done at the same time. This is the key that unlocks true parallelism, making your applications way faster and a whole lot more efficient. So if one thread is one worker, multithreading is the entire kitchen staff in full swing during the dinner rush. You've got one chef searing steaks, another plating salads, a third working on dessert, all at once. And the result? The entire multi-course meal gets to the customer's table so much faster. All right, enough theory. That all sounds great, but how do we actually pull this off in C#? Let's get our hands dirty and look at some code to see how we conduct this whole orchestra.
Okay, we're going to walk through a really basic code example here. The goal isn't to build something super complex, it's just to see the fundamental mechanics of how you create a couple of threads and set them loose to do their work.
The first thing you'll probably notice is how surprisingly straightforward this is. You just create a new thread object and you tell it which method it's supposed to run. In this case, perform task 1 and perform task 2. Then you just call .start on each one and boom, they're off to the races.
So what are these amazing tasks actually doing? Well, nothing too fancy. Each one prints a message. Then it calls Thread.Sleep to just pause for 3 seconds. This is a super common trick, by the way, to simulate a long-running job, like querying a database or downloading a file without having to actually do it. Now, there is a super important piece missing here. If you just start these threads, what's to stop your main program from just finishing its work and exiting before they're done? Nothing. That's where a method called join comes in. You'd call Thread.1.join and Thread.2.join. This literally tells your main thread to pause and wait right there until those other threads have finished their work. It's like a symphony conductor holding that final pose until every single musician has played their last note.
This all sounds pretty incredible, doesn't it? More speed, a UI that never freezes. What's not to love? But as you probably know, in software development, there is almost never a free lunch. Let's talk about the big trade-off you're making when you step into the world of multithreading.
I mean, the benefits are awesome, no doubt about it. Your app can get a serious performance boost. Your user interface stays snappy and responsive, and you're finally using all those powerful CPU cores that we all have on our machines these days.
It's a powerful, powerful tool, for sure. But all that power brings with it some new, tricky challenges. So, what's the catch? Well, here are the two big ones. First is thread safety. Imagine you have two threads trying to withdraw money from the same bank account at the exact same millisecond. Who wins? You have no idea. That's a race condition, and it can silently corrupt your data in ways that are a nightmare to find. The second challenge is just complexity. Let's be honest. Code that does multiple things at once is just fundamentally harder to reason about, write correctly, and debug when it goes wrong. Let's go back to our restaurant one last time, because it makes this super clear. Imagine the chaos if two chefs tried to use the same pan on the same stove at the same time without talking to each other. That's a race condition. To avoid disaster, the chefs have to coordinate, they have to communicate. And it's the exact same with our threads. Okay, so let's bring this all together. What should you take away from this? How do you actually become the conductor of your own application symphony?
This line from our source material really just nails it. When you use multithreading, you're not just a coder anymore. You're an orchestrator. You're making sure all the different parts of your application play together in harmony to create something that's efficient, powerful, and beautiful to use. So if there's one single thing to remember from all of this, it's this. Multithreading is an incredibly powerful tool, but using it successfully is all about finding the right balance. You have to weigh the amazing performance gains against the new complexity you're adding to your code. Ultimately, learning this skill is about going from a solo musician to the conductor of an entire orchestra. So the only question left is, what kind of harmony will you orchestrate?